Let's create a subnet first. Rename to Coke Splashes. Change the color to red. Let's dive inside. Create a geometry node. Rename to geometry geo preparation. Change the color to green. Let's dive inside and load the RFBX file. Let's convert the units here, just to scale up in the word. Create an unpack node. Delete some attributes that we don't need. Delete everything except UVs and the name. Create a blast node just to separate each piece. These nodes we keep the cap. Copy this node, keep bottom, copy again, keep logo. Logo is this part here, which will be the logo of the Coca-Cola. Copy again and copy, keep liquid. Here at the bottom. Here's just the logo. And here is the liquid. Delete non-selected here. Delete non-selected in all the blast nodes. Okay. Let's merge this again. For each of these blast nodes, we can create a checkpoint. Alt cap, black color, copy this node. This is bottom, alt bottom. Copy again, paste here. This is logo. And the last one is liquid. Liquid inside the bottom. Create a checkpoint, find a checkpoint here. Alt Coke bottom. Change to black color. The first step, we need to create the water drops in the surface of the bottle. For create that, let's create object merge here and assign the out bottle just for organize our network. Apply a subdivide node like 2 in subdivision. Before subdivide, we need to clip because we don't need the inside piece, just the outside geometry. Create a clip node. Rotate that in 4Y direction. Move the clip up, like here, at the tip, and keep just below pieces. Create a delete small parts just to keep the outside of the geometry. Extract the largest piece and you can go to subdivide. Now we can scatter some points at the surface, like 4,000 points, and reduce the relaxed iterations to 1. Create a copy to points. Create a little sphere and create the copy to the points. Okay, let's reduce the size of the sphere, 0.1. It's still too big. Change the polygon primitive type to polygons and the frequency around 8. Create a randomize attribute just to randomize the p-scale here. P-scale. P-scale should be 0.05, 1 dimension, global scale around 0.11, like this. Let's create a mountain, because if you observe here, all the drops is too spherical. We need to create a small deformation for each sphere. Create a mountain node. I think it's enough. But here, all the spheres are pointing to the same direction. You need to randomize the direction too. Create another randomize attribute. The attribute name should be orient. Dimensions 4. And here in distribution, change it to direction or orientation. Okay. If you see at the clip the geometry, not this one, this one, you can see that you have the drops overlapping the inside of the geometry. We don't want this result. We need to subtract here, make a Boolean subtract for the drops. But first, let's do that. We need to fill this geometry, polyfill. At the top you can change to triangle fan and add a small edge loop here. And create the Boolean. Boolean subtract. Before connecting this to the Boolean, let's create a file cache, because the Boolean operation should be saved in cache to avoid the processing. Cache drops. Time independent disable. And connect this polyfill here. And save the cache. Okay, it's working. Now let's fix this geometry here. Because we have too many polygons, we don't need so many polygons in this geometry. We can convert this to VDB. VDB from polygons. The voxel size should be 0.000305. The VDB is converted. Let's create a VDB smooth SDF, just to smooth connect the spheres. Let's convert back this to geometry. Convert VDB to polygons and save the cache. File cache. Change the name of the cache drops mesh. Disable time independent cache and save. Create a name here just for shader organization. Change the name to drops and create a little checkpoint here. Out drops. Change to black color. And you can merge here at the final like this. Okay. We need to create the bubbles from inside the liquid. To do that, let's create object merge. We need to reference this out liquid here to scatter some points inside the liquid. Out liquid, okay, let's go there. Let's subdivide just one iteration, okay. Let's create a peak node to offset the normals inside, like just a small value 001 negative, okay. Convert this to VDB from polygons, because you need to scatter some points inside this geometry here. We don't need too much resolution, like 001, 005 is okay. And the fog should be, the type should be fog density. Create scatter points. Okay. Around the 3000 points. Let's create a copy to points to copy some spheres here. We can just copy this sphere here, the same size. You can copy too these both randomized attributes here. Let's color to green, make a copy, paste here, and connect it after the scatter. Let's just adjust the size. I think it's too big, still too big. Let's reduce a little bit. In global scale here, from the P scale randomize, should be around 0.06. I think it's enough. That's the bubbles inside the liquid. Create the name attribute. Call it bubble. And create a file cache. Name to cache, bubble, liquid. Disable time independent cache, just of single frame. And create a checkpoint here for organization. Ouch, bubble, liquid. Change the color to black. We can merge the bubble liquid here, just to merge all the geometry we need in the shader. Okay. I think here we need to subdivide the cap. I think don't need subdivision. The bottom needs some subdivision here. Let's subdivide. Just one iteration is enough. The logo needs a subdivision too. Subdivide. Let's check the liquid. The liquid needs a subdivision too. Subdivide. Just one iteration. Okay. Create a file cache here, just to avoid the processing of the network. File cache. Cache. Coke. Bottle. And disable time independent cache and save. Now let's start working with the splashes. Let's create the splashes now. Create a geometry node. Rename it to simulation. Change to green. Let's dive inside. Create object merge. Just to import our glass, our bottle glass. Here. Actually, let's load our Coke bottle. Just create a blast node. Keep bottle. Delete non-selected. Let's delete all the attributes that we don't need. Create a clip node. Here we are going to prepare our collider for the splashes. Let's rotate the clip 0, 1, 0. Move up. Like that. And just keep it below the plane. Let's delete small parts and extract the largest piece. And create a polyfill here. Change it to triangle fan. Add a small edge loop. Okay. Let's create a collision source. And create a checkpoint for the out gel. And create another checkpoint. Alt VDB. Change color black. That's the first step. Here, before the polyfill, after the polyfill, let's scale a little bit to adjust the simulation scale by 2. And rename this to scale to sync. Now let's create the source, the emitter of the splashes. Create a sphere. move the sphere here. The scale of the sphere should be 0.15. The center of the spheres should be around here. Let's create a mountain node. A mountain around 009 and the element size 0.26. Let's create a transform node just to scale the position and transform of the sphere. And move like this position here. Let's create a flip source. Flip top source. Change the voxel size around 0.005. And the particle scale should be the same size of the voxel size. Let's see how many points here. Let's adjust just the position here in the center. Zero 0.15, 0.56, 0.47, and 0. Let's scale to scene around 2, okay. Is enough. Let's create a point velocity. Add velocity in x like minus 7.5. Let's see the velocity direction. Let's scale the length of the velocity. Here change it to keep incoming. And add a core noise. Don't need to be animated. Scale like 1.5, 1.4. And surreal size around 0.0, 0.15. That's okay. Here in the Y velocity, add 1, just to make the fluid going up, and create a checkpoint. Alt emitter A. For the simulation working the interesting way, we are going to create 3 simulations at the same position just for the fill of the splashes. Let's change to black and create a flip and create a DOP network. Rename this to splash scene A. Connect this here and connect the auto geo in the second input. Let's dive inside. Let's create our fluid network here. Flip object, flip solver, connect here. Let's add gravity. Let's create a merge and create a static object for the collider. The static object should be this AutoGeo. Let's paste the value here. Here, at the proxy primitive proxy volume should be the AutoVDB from our collider. Let's change it here to reintersect max axis to 100. Let's disable all the physical parameters of the colliders and delete the SOP path here. We don't need this collider. We don't need this parameter here. Let's create a volume source for the emitter. Change this here to source flip and point to the first context geometry. Activation frame should be the first frame only. Here the bounding box, we don't need to be so big. We can reduce the bounding box size here. Like 5, 5, 5. And move up a little bit. Let's adjust some parameters here at the flip solver. Let's copy this value first. That should be the particle separation for the flip solver. Copy parameter here. Go inside, flip object, paste here, paste relative reference. That should be the scale of the particles. In sub-steps, we reduce the time scale for 0.16. Mean sub-steps remains the same, maximum sub-steps should be 10. In the particle motion, we add an ID attribute, separation, apply particle separation. In volume motion, we need to activate the surface tension here and change to 45. Let's create our cache for the first emitter. Create a DOP import field. Copy this node here, flip object just to copy the path, and paste here. The DOP node should be the flip object, and here change to particles. Here in the object should be the flip object. Create attribute delete. We just need a few attributes from the simulation, just the ID. Delete all other attributes here and create a file cache. Rename the file cache to cache splashes particles A and save the cache. That's our initial simulation here. Let's create a trail to compute the velocity. because we don't save the velocity in the cache file. Compute velocity, match by ID, evaluate with frame range. Let's see this particle surface, color the particle surface. Create particle fluid surface and change here to the particles. Visualize the velocity. Change here the velocity range to 2. That's the first emitter. Let's import our camera here just to see, to visualize the animation. Alembic archive, camera render. Let's load our camera. Here at simulation, we need to scale back the simulation for the correct position. Create a transform. Restore scale. Restore scale. Copy this value here to copy parameters. Paste a relative reference. 1 divided by this value. And create a little checkpoint here. Alt water splash. Color black. Create a name attribute for the shader. And change here the name to splash. Let's see the camera. Let's create more 2 caches of the flip simulation. Let's do that. Let's organize our network here. Compute. Rename this trail node to compute val. Organize our network. Move this here. Copy these nodes. Let's disable the manual update just to avoid the refresh of the viewport. Copy this node. We need to copy these nodes from the sphere to the simulation. Ctrl C, Ctrl V. Rename here to emitter B. Splash scene B. Ctrl C, Ctrl P. Move this by the side and rename this to C. Splash scene C. You can copy this node too. Ctrl C, Ctrl V. Here, Ctrl V again. This should be for this splash A, splash B, and splash C. Let's change the color boxes here, different colors. Dark, purple, and blue. And rename our caches here. Particles B, particles C. We need to merge all these compute velocities here and create the other caches just adjust the position and the mountain to be a different value. Here, let's change the mountain offset to a different value. Like this. We can change the position too. Just upwards, okay. At the third sphere, we can change the position and the mountain too. Okay, this should be different values here. The first is emitter, second emitter, and the third emitter. Like this. Okay. And save the other caches here. Let's save. We need to merge these caches, okay, and let's see the result. For the camera. Let's make the flipbook. First, let's change the resolution, the time range for 20 FPS and the end frame to 115. And make our flipbook of the simulation. That's the result of the particle simulation. Now we need to remesh to make a mesh version of these particles to be ready to render. Let's go. Go back to simulation. Let's move down these nodes. The merge here, we need to create a particle simulation. Particle fluid surface. We need to change it here to surface polygons or surface polygon soup, doesn't matter. Let's copy the voxel resolution and paste here the fluid surface. That's the mesh. Let's delete some attributes here. We don't need all the attributes. We need just to keep the velocity, just to make the motion blur at the render. Let's create the file cache here. Rename the cache to cache splashes mesh. Connect here and save the cache. The cache was done. Let's create a smooth operation here. I think there's some noise areas that we need to smooth. Change the strength to 50. Okay. We don't need anymore these particles fluid surface. We can delete that. We just need the restore scale and the name. Let's create a flipbook for that simulation. We can change the color just to see the different color for the fluids. Color like bluish. Let's make the flipbook. That's the result of this simulation. Now you can start the shader and look dev render in the Redshift using Solaris. Let's go. Let's create a lobby network. Change the name to lookdev. Coke. Let's dive inside. Create a SOP import. Rename to Coke. Select the path here. Jump to preparation. Alt Coke bottle. Change the sublayer style to copy SOP layer. Okay, let's change the background of the viewport here. That's the items from the Coke. Let's import our camera here. Cine. Import cameras. Let's select our camera. Camera render, Coke splash, position, camera transform, camera render, animation. Okay. That's our camera animation here. Let's merge this node with the splashes. SOP import. Splashes. Select the splash geometry. Simulation. Alt water splash. Change the sublayer style. Let's see on a specific frame. Okay. Let's create a material assign. Material library first. Material assign. Create our node Redshift. Rename the Redshift to RS. Coke Beauty. Change the resolution here for Redshift to 1. For this resolution, Full HD. Change the camera for this camera here. Let's give some space for the lights here. Let's activate Play Monitor. Change the Redshift to Advanced and increase the threshold for the sampling. We don't need to write high resolution sampling right now, just the previews. Let's create some materials here. We need few materials Redshift. First we need RS cap. Let's copy this. Materials. Bottle. Make another copy. Logo. Another copy here. Drops. The drops for the surface of the bottle. Another copy here. Liquid. This is for the liquid inside the bottle. Bubble liquid. And the final material is splash. Let's assign in the material for each geometry. Autofill materials here. And assign 7 materials. For the splashes, we assign the RS splash. Bottle. Material bottle. Bubble. Bubble liquid material. Cap. cap material for redshift, drops, drop material, liquid material, and the final geometry is logo for the logo material. Let's create some lights here. We need a dome light and 3 area lights. Let's create the first area light, call it the main. Another area light, call it the hing. And another area light, call it the fill. Let's adjust the position for each area light. Let's disable the dome light and just adjust the position for the main light. Should be almost the frontal. Ring light is from the back. And the fill light is from the side. Let's adjust the size of the lights. And enable our dome light. Let's apply our ADR file. Studio Small. And for our background render, for the area light, we need to change here at the dome, backplate enable, and select a gradient texture here. That's the texture we are going to use in the background for the refraction. That's texture, gradient texture here. Let's see our render with the default shaders. Let's disable the camera light gizmos and start to tweak the shaders. The first shade we can tweak right now is a splash. Let's adjust the transmission here. You can disable the roughness, actually zero out the roughness and increase the weight of transmission. And increase of IOR to 1.7. Increase the color to 1. Okay, let's do the same for the drops. Enable the transmission. Zero out the roughness and increase the IOR to 1.7. Let's change the cap for our red color here. Okay. Decrease the roughness a little bit and decrease the weight for the color. Let's change the material of the logo. Create a texture here. Our logo texture is just like this. That's the logo. Base color. Let's adjust the roughness a little bit here. Weight 0.5. Decrease the weight of reflection and increase the roughness. I think the weight is too low. Let's increase the weight of the color. It's okay. Let's change the bottle and the liquid inside color. The liquid inside should be almost brownish. Let's create a ramp. Color should be almost brownish. We don't need a ramp at first. Let's copy this color here, paste the color here, relative reference for the transmission, and enable transmission to 1. We're not seeing the refraction of the bottle. Let's see if the material is applied. Liquid. Because we need the transmission of the bottle too. Transmission to 1. And adjust the roughness a little bit. The weight of the roughness should be 0.2. And you can create a maximum noise to make a breakups in the specular here. The maximum noise should be displace turbulence, input should be word, overall scale should be 0.05, and decrease the color here 0.05 at the 3 values RGB, and apply this to reflection roughness to just break up the specular here. Create a bump material, bump map, apply this noise texture here in the input, and apply this to bump. The weight of the bump should be pretty small, 0.002. Let's restart the rendering just to see if the refresh the textures. Let me see. Increase the octaves. Oh, sorry. I applied to displacement just in the bump. Let's adjust the scale. just to see if there's some difference. Increase the IOR. Let's just see if the bottle is applied correctly to the shader, because I cannot see any bump here. Let's just see only the disable the splashes. And see just the gloss here of the bottle. I didn't see any bump here. Let me check what's happening. Bottom, maximum noise. Ah, sorry. I need to enable the displacement just for the bottle. Mesh edit. All the geometry. Subsurface scheme. That's subsurface. Now I can see some bumps here. We just need to increase the height scale and decrease the roughness a little bit. Let's set the camera. Let's reduce some information, some intensity for the lights. Let's see each light individually. Too bright here, 0.2 is enough. Let's see the arrow light with the dome light. Increase a little bit the exposure by 4. It's too much. Let's decrease by 2. I think it's enough. Let's increase the ring light. Let's exposure 10 and see what is happening. Too much. 5. Let's decrease the exposure, the ring light. The highlight is too strong. Reduce more. Almost there. I think it's 2 is enough. Let's activate the fill light and increase the exposure around 5. Too much. Let's decrease. I think the red of the logo is too dark. Let's make some adjustment here, but let's see if it splashes. Let's activate the motion blur for the splashes. For this we need to render product, render geometry settings, put the splash here, and the redshift, enable the velocity blur. Let's adjust the color, the red color for the logo. We can replace this using a mask instead of the texture. We have the texture, a mask here. We can use a mask and blend the two colors, red and white. Let's do that. Change the color to mask and create a mix, vector mix, using the mix amount, the mask as mix amount, and put in the color and create a color constant This color should be red. Another color should be white. Let's connect here. Change the color to red. We need to reduce a little bit, like 0.5. I think the light is too bright here. We can reduce the dome light. Reduce the dome light a little bit more. I think you can adjust the liquid inside too. Sorry, we need to apply the bubble liquid, the shader. That's the transmission tool. Enable the transmission for the bubble liquid. And the zero out the roughness. Let's change the color inside. Liquid, more brownish, interesting color. Let's see if it orange, more orange instead of super brown. I think it's very interesting. Let's render this frame with more resolution and see the result. That's the final result of the rendering. That's it, guys. Thanks for watching. See you at next tutorial.